Now let us do the next problem here. Find the Laplace transform and the R of C of the following signal, that is x of t is equal to e raised to minus 4t u of t plus e raised to minus 3t u of minus t. Okay, so here we start the problem by writing the basic Laplace transform equation. L of x of t is equal to minus infinity to plus infinity x of t into e raised to minus st dt. Okay, say I want to request my students that before we continue this problem, I just want you all to just pause this video and try to do this problem by yourself. Okay, just try to do the problem by yourself and then see if your answer and my answers are correct. Okay, so let's continue now. So here now we substitute the value of x of t from the given question. So here this is integral minus infinity to plus infinity. The value of x of t is e raised to minus 4t u of t plus e raised to minus 3t u of minus t into e raised to minus st dt. Okay, so now I am going to multiply e raised to minus st inside the brackets. So it will become integral minus infinity to plus infinity e raised to minus 4t into e raised to minus st u of t plus e raised to minus 3t into e raised to minus st u of minus t dt. Okay, this now I am going to integrate inside the brackets. So this will become integral minus infinity to plus infinity e raised to, so let me join these two exponential functions. So it will become minus of 4 plus s t into u of t dt. Okay, plus integral minus infinity to plus infinity e raised to minus of s plus 3 t u of minus t dt. Okay, so we know what is u of t. U of t is a unit step function which is 1 when t is equal to 0 to infinity. Otherwise u of t is equal to 0, right? So I'm going to substitute that over here. So that means the limits will become 0 to infinity. At 0 to infinity u of t becomes 1. So e raised to minus 4 plus s into t into 1 dt. Okay, plus also here u of minus t is the time reversal of u of t. Time reversal of u of t, that means u of minus t is equal to 1 from minus infinity to 0, right? That is the value of u of minus t. That means from minus infinity to 0 u of minus t is 1. So integral minus infinity to 0 e raised to minus of s plus 3 t into 1 dt. Okay, so now I am going to pause my problem and I am going to directly find the region of convergence. This is the best step to find the ROC. Okay, so here as you can see there are two terms to find the ROC, the first term and the second term. So these two terms have separate region of convergence. Okay, so like I said before, if you want to find the region of convergence, the power of the exponential must be negative. The power of the exponential must be negative. If you look in the power of this expression here, the power here t is positive. See, the value is from 0 to infinity, so all are positive values. So t is positive and there is a minus sign over here. So that means this power can be negative only when 4 plus s is a positive value. Or in other words, we can say that 4 plus s is greater than 0. 4 plus s must be greater than 0. Or in other words, s is equal to sigma plus j ohm. So that means the value of sigma, that's the real part, is 4 plus sigma. So that means the ROC of the first term will be 4 plus sigma, or 4 plus real part of s, we can write in any way we want, is greater than 0. Or in other words, sigma must be greater than minus 4. Okay, this is the region of convergence of the first term. Okay, so now let us look at the region of convergence of the second term. Okay, here, like I said before, the power of the exponential must be negative. Alright, so here if you look at this power, the value of t over here is always negative. See, the values are ranging from minus infinity to 0. So that means t is negative and there is a minus sign over here. So minus of negative t, it becomes a positive value, which means this value s plus 3 must be a negative value. Okay, so that means here s plus 3 must be a negative value. Alright, so therefore the ROC of the second term must be sigma plus 3 must be less than 0, or in other words, sigma must be less than minus 3. Okay, so this is the ROC of the first term, this is the ROC of the second term. So now I want to define my ROC such that it covers both this instance. It should satisfy both my condition. Okay, the first term, the region of convergence is that it should be greater than minus 4, and the second term it requires it should be less than minus 3. So what is my region of convergence? Such that it satisfies both my condition, the first condition as well as the second condition. So as you can see that it is greater than one value and less than the other value. So that means the only region that covers both these ROC is the region in between these two values, right? So that means my overall ROC must be, it should be greater than minus 4 and less than minus 3. So this is my overall ROC. Minus 4 less than sigma less than minus 3. This is my overall region of convergence. Okay, so now let's continue our problem. All right, so here we get integral minus infinity 0 to infinity e raised to minus of 4 plus s into t dt plus integral from minus infinity to 0 e raised to minus s plus 3 into t dt. Okay, so now this can also be written as, so now I'm going to apply integration over here. Okay, so what will happen? I will get, minus 1 by 4 plus s, okay, into e raised to minus 4 plus s t from the value between 0 to infinity. That's the first term, plus now the second one, minus 1 by s plus 3 and the value e raised to minus of s plus 3 t from minus infinity to 0. Okay, so this is also equal to, here you can see that the value of t is positive over here, 0 to infinity, and also 4 plus s. So that means this in turn will become minus 1 by 4 plus s into, this will become e raised to minus infinity minus e raised to 0. Okay, plus here this will become minus 1 by s plus 3 into, so here e raised to 0 is 1, so here because e raised to 0 minus e raised to, so here if you see, if I substitute minus infinity over here, okay, just understand that this is minus and this s plus 3 is also a negative number, right? This s plus 3 is also a negative number. If you look at the condition over here, it's written over here, s plus 3 is less than 0. So that means this s plus 3 is also a negative number. That means this s plus 3 that you see here is also a negative number. So negative with negative becomes a positive number. So if I substitute t is equal to minus infinity, then that infinity will also become into e raised to minus infinity. Okay. So this is equal to, so we know e raised to minus infinity is 0 and e raised to 0 is 1. So this term will become 1 by 4 plus s, and this term will become minus 1 by s plus 3. Okay. Now if I cross multiply, I will get s plus 3 minus 4 minus s by s plus 4 into s plus 3. Okay. S and s gets cancelled. 3 minus 4 is minus 1. So the answer is this is equal to minus 1 by, if I cross multiply these two, I will get s square plus 7s plus 12. This is my final answer. And the ROC is defined as minus 4 less than sigma, or you can write real part of s, less than minus 3. The reason why I am writing real part of s or sigma is because in the question paper, this format can be asked anyway. Sometimes they can ask sigma, they can put sigma over here, or sometimes they can put real part of s. You see, so I want you all to familiarize with both the names. Okay. So this is the answer. Now I am going to draw my region of convergence in the S plane. Okay. So this is x-axis is sigma, y-axis is JO, this is 0. So the value of sigma must be between minus 4 and minus 3, right? So I'm going to mark, I'm just going to mark roughly, this is minus 1, this is minus 2, this is minus 3, this is minus 4, and I think I will also mark minus 5 also. Okay. So this is the value between minus 4 and minus 3. Yes. Okay. If you want, you can also mark the poles also over here. Here the poles over here, look at the denominator. This is the equation. So the poles are s is equal to minus 4 and s is equal to minus 3. You can mark that also over here. Minus 4 and minus 3. The poles. Okay. So this is your answer.